everybody. Taylor White here. We are downtown St. Louis at CK Supply in the Hillbacks Tech Center. Today, we're going to talk all about MIG welding. If you saw our last video, Steven, he went over the first of 4 transfer modes with MIG welding, or as we like to call it, GMAW. That first method is short circuit transfer, right? Just to recap, why do we call it short circuit transfer? Because it's the only method that's actually dead shorting into the weld puddle and creating that popping, that sizzling sound that everybody thinks about when they think about normal MIG welding, right? Not everybody knows that there's other transfer modes. So that first one, what's it good for? Thin stuff, right? We can go down to 20 gauge, and we have some capability to get to the higher thicknesses like 1/8 inch, 3/16 maybe. But after that, short circuit starts to lose its penetration, its abilities to properly fuse metal together, especially for those thicknesses, right? So its capabilities are at the lower end of the thicknesses of material. But how do we weld thicker material? Well, now we start getting into those other transfer modes. So now we're gonna start with the second transfer mode, globular. Why is it called globular? Well, it's kind of like the names are explanatory. Short circuit, it's the only method that's short circuiting. Globular transfer, right? We're no longer short circuiting into the weld puddle. We're actually gonna be balling up. The arc is gonna burn back far enough. It's no longer hitting the weld puddle, and it's going to ball up the filler metal, almost about twice the size of the filler metal itself. So it's 035, it's gonna be about twice the size of that. Balls it up and actually flings it into our weld joint. So let's see what it looks like. And as you see with the globular transfer, really what we've done is we've just started the transition from the different transfer modes, right? So while we start with short circuits, the first one, we step into globular, but globular is really just a middle of the road between spray and short circuit, right? So that arc is, the voltage is up higher, and we're sitting at 25 volts and 260 inches per minute. So that voltage is up, which means that arc length is farther away from the end of the electrode, the wire. So it's melting before it gets into the puddle, it's balling up, and the force of the arc is actually throwing that filler metal into the weld puddle. Now this is awesome because we can start getting into those thicker materials. We can start getting into 3/16 and up, give till 3/8 maybe. Now with globular transfer, you're getting some of those perks that you get to go into those thicker materials, but you also have some downsides too. And one of those is the amount of spatter that you'll see in these welds, because that big ball of molten filler metal is just kind of being thrown around, and it splashes in there, sparks start flying. It's doing it a bunch of times a second. So you end up with more spatter, more sparks, because you have that increased voltage, and that's a good sign that you have a lot of voltage is when you have a lot of spatter and things like that. So another one of the downsides that we have with globular transfer is that now we're stuck welding metal that's thicker than 1/8 inch. Anything underneath, it's actually too hot, you're having too much penetration, and you're gonna burn through usually. You're not gonna have a good looking weld, it's gonna be too hot, you're gonna have distortion, because as things get hotter, they warp more. So you're also limited almost in position too. You really want to keep it to a flat horizontal position. You start getting overhead, like I said, you have a lot of spatter. It's a pretty hot weld, so it's not desirable. A lot of people want to think that They see this kind of process and this transfer mode, and they're thinking that somebody's actually got their machine messed up. Hey, your settings are off. You know, you're having too much of this and that. But really, they're in a different transfer mode. They're getting more penetration. They're still welding in a proper manner. It's just the in between short circuit and spray. We're now in globular. So not always desirable. Has its place. A lot of times people can run this and use 100% CO2. It's a cheaper gas, and you can still get the same results. So yeah, catch us on the next episode. We'll talk about the spray method and the pulse spray, which is, you know, it's only specific to a machine that's capable of doing it. Our Delta Weld 350 here is capable of doing the pulse spray method, which is why we're using this machine particularly. And you know, that'll be a real interesting one. So hopefully you tune in for that when that comes out. If you like this video, go ahead and give us a like, give us a share, give us a follow. And you know, also in the tech center, just to say it, we offer training classes. So if you want to learn about MIG, TIG, stick, oxy-fuel cutting, look on our calendar on our website. We offer 8-hour classes. We have an intermediate class for those as well. And if you want to demo any of these machines and you need to check out something, just go ahead and contact us and we'll try to help you out as much as we can. All right, guys, thanks for tuning in. See you next time.